This is going to be a quick example on how to write the equation of a line of best fit. What we have here is we have a scatter plot that's already been created for us. If you did not have it already created, you would take whatever data they gave you and you would plot it on your coordinate plane, and then you're going to draw a line through that data. Our graph has already been completed. They put our scatter plot points on there for us. As you can see, there's mosquito bites per camper. So the number of hours that campers are outside and the number of mosquito bites they can receive. Or they did receive. So as you see here, there is a positive trend with the data. So when we draw our line of best fit, we're going to draw a positive line with a positive slope. Okay, so here I have my line of best fit, as you can see, and I played around with this and wrote a couple different versions, and this is the line I found that fit the best. So what you're going to see here is I've got 1, 2, 3, 4 points above the line, 1, 2, 3.5 points kind of below the line, 2 points the line actually goes through. The big thing to pay attention here is, does your line make sense? My line is not going to be the same as your line. All of our lines should be similar, but we're humans, we're not robots, so we're not going to do the exact same thing over and over again. So everyone's line should be in the same general place. It should go through the center of the data, as close to the center of the data as possible, and everyone's line here should have a positive slope because our line has a positive trend. So the first thing we're going to do to write this equation is we're going to pick 2 points on the line. It's very important that they are on the line, not data points. We don't want to use any of these points not on the line. Those points are not going to help us. Those points are data points, but they are not points for our line of best fit. So I'm going to use this point because it goes perfectly through a coordinate. That's point 110. I could use this point. This point, however, goes a little bit above the coordinate line, so I kind of would be guesstimating it's about probably like 531 or 532. We could use that one. Or this one is exactly through the data point, and that's going to be 740. This is at 740. I'm going to choose to use the one right here, the 110, and the 740. So I want you guys to see the points we choose for our line of best fit do not have to be points from the scatter plot. They just have to be points on the line. So in this case, I'm taking 1 point from the scatter plot data and 1 point that's actually on the line. So we're going to use the points 110 and 740. All right, we're going to label these points x1, y1, because we're going to use these to do our slope formula, and x2, y2. So we know our slope formula is y2 minus y1 divided by x2 minus x1. So when I do this, my y2 was 40, my y1 was 10. My x2 was 7, my x1 was 1. Now subtract 40 minus 10 is 30, 7 minus 1 is 6, 30 divided by 6 is 5. So I have a slope of 5. So the slope for this line of best fit is 5. We're going to remember that. Now, side note, if you drew a different line, if you chose different points, you're going to have a different slope, obviously, because you have a different line. So your slope line might not have a slope of 5, but the slope you got should be closest. Maybe 5.5, maybe 4.5, maybe 6, maybe 4, maybe 3.5. Anywhere around 3.5 to 7.5 is going to be good, okay? Your slope is going to change depending on the line you drew. All right, the next thing we need to do is we need to determine the y-intercept. So there's 2 ways we can do this. We can look and kind of see, all right, hey, my y-intercept, it looks like it crosses right about here. It's a little bit above 5, so maybe the point is 0.06. Again, depending on your line, your y-intercept might be 7. Your y-intercept might be 10. Your y-intercept might be 2. As long as it's somewhere around, I would say probably this general area, your y-intercept would be correct, okay? In between 0 and maybe 12 would be possible for there. If your y-intercept is somewhere like up here, yeah, you're probably not drawing the correct line. So we can guesstimate to be about 0.6, or what I can do is say I have this, we're going to use the equation y equals mx plus b anyway. Hey, I've got an x, I got a y, I've got an m, let's plug those in. So 10 equals 5 times 1 plus b, 10 equals 5 plus b, we're going to subtract 5, b equals 5 here. So our y-intercept, they said is 5, we said is 6. We're guesstimating. We can go with a 5 if you want to. So I'd say anywhere between 5 or 6 or 4 would be the appropriate answer. So we'll say B here is 5, and I'll change this one that we guesstimated to match. So we have a slope of 5, we have a y-intercept of 5. That's everything we need to write an equation in slope-intercept form. So y equals 5x plus 5 represents the situation. So if we're going to interpret this, our rate of change, our constant rate of change is 5, and that means 5 bites per hour. Students are getting 5 bites per hour from mosquitoes being outside. And then the y-intercept is our initial value. So our initial value is also 5. So that means that we're getting, whoever went out there, all the campers, the students, whoever, they had 5 bites to start with. Okay, so someone had already gotten bitten up by mosquitoes. So they had 5 bites to start with already, and then everyone's getting 5 more per hour. So, I mean, we live in the South, so it's not too bad, I would say, for a bunch of campers. But some places that would be really bad. And we can always use this equation to make predictions. So, for example, if I said, guys, if the campers were outside for 10 hours, okay, if you're outside for 10 hours, how many bites would people be expected to have? All you do is you take your equation and say y equals 5 times 10 plus 5, that's 55 bites. So we can use our equations to make predictions. We can use our equations to interpret the meaning of the rate of change, the meaning of the initial value. All right, and this example should help you better understand how to write an equation for line of best fit.